put this way. And predictive control, the same thing. There's a book, this thick, just talk about predictive control. But concept-wise, I'm going to show you the concept. After this concept, you understand the whole concept, the math and physics. Then you will be able to read the book. Now, all this, I'm talking about linear system. I'm talking about the linear, we are not talking about linear system. We are talking about linear system only. Even today in the aircraft, everybody talk about linear system. And the aircraft design is also linear system design. So, in this class, we are supposed to have, to learn all this. Every single bullet will take about 1 to 2 weeks minimum to explain the whole detail. And I will focus on the mathematics and the physics. So every single math, they come up with some physical meaning or some intuitive feeling. Okay, for example, let me just turn this off. I think it's this control techniques. I finished these chapters, and you can go to download it. And today I'm going to talk about this guy. I finished because last week I think my postdoc already show you polynomial differential equations, but I add some few other things here, and I will explain a little bit here so that some of the students just say that they forgot almost everything here. So we want me to take it, explain it a bit more. So I'll take another few minutes to explain what is the polynomial differential equation. Okay. This is the simplest physical system you can ever have. Just a mass. How is a displacement and a force? This is a Newton law, right? Simple. This is a mathematical model for a Newton law. Okay. Now, so this is a second order equation of motion. It's a differential equation of motion. M d squared x1 dt squared equal to f. Now, the important thing here is, if I write into a simple form called mx1 double dot equal to f, then m larger than 0. This is the differential equations. Second order differential equations. The Newton law. What is the big deal of this? What's the big deal of this? What is the most important meaning here? Can m be negative? Can this m be negative? I'm asking. Mass has to be positive, right? Cannot be negative. True or false? True, because I say it there. All right. Now, if I write in terms of first order equation, then I write this way. I say x1 dot equal to x2, mx2 dot equal to f. And do that. So the second order equation becomes first order equation of motion. However, now I have two equations rather than one equation. Then what is the big deal of this? Why I want to do this? Why? Now I introduce a mattress equation. Now I have called matrix equation of motion. The x1 dot, x2 dot equal to matrix 0, 1, 0, 0, and then the x1, x2 plus their m equals to f. But any control design, nobody, almost nobody, except maybe few, like me, use the second order. All the control design use the first order equation of motions. So, if you learn control, you got to learn the first order matrix equations. That's what I call matrix equation of motions. And just don't look at this. You can just look at the math. You have to look at what it means. Analysis going on in these matrix equations. All right? This is called defective matrix. 0, 1, 0, 0. What do you mean defective matrix? Anybody heard about defective matrix? No? Yes? No? Anybody heard about defective matrix? Yes or no? No? Okay. Let me explain to you. This is important. So when you look at these equation of motions, don't just look at the mass. You have to look at something else in the middle. If we solve the eigenvalue of this 0, 1, 0, 0, what is the eigenvalue of 0, 1, 0, 0? 0. Okay. The Newton law I call rigid body motions. The eigenvalue of the rigid body motion is 0. Now you learn something. Because eigenvalue of a matrix, eigenvalue of a rigid body motion are 0. Okay. Understand now? Alright. But eigenvectors, what is the eigenvectors? You heard about eigenvectors? Anybody learn about eigenvalue and eigenvectors? Or you forget about it? Forgot it already. Oh, don't worry.